Thank you, Martina. And this is going to be a long series of thanks to the organizer for the occasion to have this conversation on the archive and the content and the legacy from the ESO public survey, but also as a person who joined from the beginning with the survey management plan of the ESO imaging survey. It's really a sense of real happiness then is to see the end-to-end process from the beginning to the publication and the scientific exploitation of this data. So on to the outline of the structure of this conversation. I'd like to give you some information about the ESO Science Archive facility, and then how do users put content into this archive through what we call the ESO Phase 3. And then I'd like to share some statistics on the ESO Public Survey. So archive at ESO.org is the access point to the data from the LACIA Paranal Observatory, which includes future public survey and also the ELT. So this is the place where all the data will be accessed and where they go. And the archive, like anything else at ESO, has been part of a long journey, of a long development, starting from the team set up by Van der Laan, where the goal of ESO was to assign time at the telescope to what we call the end-to-end process. And the archive is an intrinsic part of this science operation. So the ESO Science Archive is collecting now 20 years of science data, and for some of our users is considered at the same fashion as a telescope facility, where data you can formulate your scientific question and obtain the data. And a big effort has been developed lately to make it really a unified access of the LACIA Paranal data with ALMA. And I think I'll ask my chair whether we are going to have a deployment of the ALMA previews. Yeah. Past tense, so that is done already. So you can access the LACIA Paranal data and have previews of the ALMA data from the same interface. Archive operation is the bedrock upon which everything else stands. Data come in and flow out. The ESO archive cannot claim to be huge in terms of volume, about 1.2 petabyte, but is very complex. And in fact, we have 50 billion of header keywords to be able to manage this data holding and capture its complexity. Also, the night inflow is about 300 gigabyte, and the outflow is about half a terabyte every day. So, and big development will come with foremost moons and ELTA, you name it. A big change in the way the archive was open to the community came in 2005, with the access open also to non-member states. Anonymous access was implemented in 2018. And we're very happy to have the revamped download portal in 2020. And since 2021, whenever you have access to the raw data, you see automatically whether you have products as well. This is, you are familiar with the home page of the archive, but also as API, you can access the data either through the raw interface or directly from the user portal account. And now on to the archive interfaces. The Archive Science Portal is a highly interactive, highly intuitive interface that allows science data product to be accessed at a click, When we talk about science data product, we mean the data type that you see here. Data holding contains of the order of 2 million calibrated spectra, about 1 million images, 500,000 catalog, 500,000 science cube, and also optical calibrated visibilities. A key of science data product is interoperabilities. And in fact, from a statistic of TELBIB, we know that 50% of science papers based on ESO data are also using data from other observatories. And you see example here of such an interoperability. For example, the gravitational wave detection, the obvious complementarity between ESO, HST through ESA Sky, but also, as we said before, La Silla Paranal data with ALMA. And this all together also with the availability of catalogs through the catalog query interface. All this is possible because the Archive Science Portal and the data that are published through the ESO Archive are based through VO standards and have VO services inside. And in these slides, there is a summary of all the interfaces, protocols that have been adopted and are part of the new interfaces. This is also to mention the programmatic access, which is also a possibility in addition to the Science Archive portal. Now, we are talking about La Silla Paranal data and data that come in and are processed at ESO, but is also a way to publish data from external provider. And in fact, raw data and processed data, either from external sources or internal sources, are part of the content that is available through the ESO Archive. The difference between external and internal science data product is mostly about providers who provides the data, but is also the scientific goal behind the processing. For external data product, the processing of the data was tuned to a particular science goal. For the internal process product, there we have a uniform processing, which is, of course, the same applied to all acquired data. We also have a source catalog and catalog that are published into the ESO Archive. One key concept that applies to all this product is the provenance information, which is able to connect and trace back the photon origin through the raw data to the processed data to the final measurements in the catalog. The pillars of science data product is trust, in the sense that the data needs to be understood and well documented, so that any science user can assess whether such product is sufficient to address the specific question at hand. In a sense, we don't mean perfect, because perfection is relative, it depends also on the project, but certainly in quantitative, in physics, in astrophysics, we have the concept of error, which is the quantitative way to measure whether a product is able to answer scientific questions. The objectivity and reliability of this error and the physical quantity is achieved through stewardship and curation. This is achieved with two pillars. One is important quality control through well-documented scientific pipeline, through a calibration plan, and through a QC process, but also through phase 3, which is the publication process, which is also using an audit process, which looks at the integrity of the data product, but also the consistency, the compliance, and the completeness. And it's based also on having a consistent release description, which is the identity card of any data product and enables additional scientific exploitation. Now, the question is, what is the advantage for a data provider to have his or her own science product in the ESO archive? In a sense, it could be for the data visibility because of the data releases that are advertised in the ESO newsletter, but also on the science data portal, and the increased citation via release description, and also to complete the end-to-end process and have the data in addition to the refereed publication published. But also ESO is aware of the work and also the engagement that requires to publish science data product. So ESO is minting digital object identifiers, which are associated with data collection, and they are equivalent of the DOI for a refereed publication. And this is also a way to recognize the work into making a science data product. In addition, the publication of science data product in the ESO archive allows the long-term preservation. It allows a data curator to really understand how to make calibrations quantitative and capture in the other information. And also, these data are not in splendid isolation, but they live together with the multi-wavelength, multi-instrument, and also the time domain science, which is available in the Science Archive because of its nature and its long-standing. Also, more and more, our community is going towards the paradigm where open science is key, and open data is an important pillar of open science. And of course, building trust means that data are used, are discoverable, and also increase their legacy value. I want simply to show here what the digital object identifier web pages where they are created at ESO and what information they capture. An important aspect is also to advertise the data curators and the information about the data collection. One way to learn about the effectiveness of these services for the community is to see the impact in terms of archive user, which we capture through the user IDs, through the access with the user portal. And we have a steady increase with of the order of 7,000 active users as of 2 years ago. And in terms of refereed publication, now our library team is all very active and also very severe in assessing and classifying the origin of refereed publication. But in the last year, we have seen a steady increase of what we called archive or PI plus archive publication, particularly in the last couple of years. Archive only, which means none of the authors were overlapping with the PI or the COI of the proposal out of which the data were acquired. And that makes up nearly 25% of all the publication, refereed publication based on La CIA paranal data. And about another 15–17% what we call PI plus archive. So these are refereed publication whose result was achieved by the combined use of PI data and only in conjunction with additional archive data. So archive is really playing an important role, and you can see as independent between bracket telescope facility, which is providing new interest and new life for the ESO Science data product. Now, this perhaps is something that may trigger some interest as PI, And it's about some statistic about public surveys and data use. And here I would like really to thank Uta and the library team for all the support. So this is where the story starts, which is the data acquisition. And this was a long journey, started in 2010 with the scientific operation, and it ended in 2022 with the last observation taken at the VISTA telescope, and you see also for the VST. That data acquisition consolidated in data releases, and here you see a footprint of data product in the ESO archive. So this is the present, what's available in the ESO archive based on those data acquisition. And this is the near future. And I would like to thank the PI of the ESO Public Survey for their contribution and their announcement for the data releases to come. So this is the near future, the new data that the ESO Public Survey are going to deliver for publication in the ESO archive. And this is important, let's say. It's another way of seeing the success of the ESO Public Survey in terms of statistic of refereed publication. Again, many thanks to Uta for sharing this data with us. So since 2010, the ESO Public Survey have totaled 1,584 refereed publication. And it's very interesting that they're very active. This is plus 20% since 2021, which was when I had the last statistic on this aspect. If we are evaluating the cumulative citation over the entire public survey project, which are 17 imaging survey plus 4 spectroscopic public survey, we have a total of 71,110 citation, which is impressive. And of this refereed publication, 26% are from archive papers only, which means colleagues in the community that had no overlap with the survey team, that they use the science data product for their own science, and additional 12% that are archive PI. So, guys, this is a testimony to the profound legacy of this project. And yeah, so there is a large community that accesses this data from 100 distinct nations, and the number of IPs that access the Science Archive of the order of 25,000, according to the updated statistics. Now, this is very specific to your own, particularly public survey project. I like to start with the cumulative curve for the catalog facility. And we have of the order of 30 catalog published. Here it's multiplied by 10. We have of the order of more than 2,000 users. And each of these users carry out about 18 queries. So users tend to come back, they're happy with the catalogs, and they query them again. The top curve here is the cumulative download in terms of volume. And yes, you may recognize some of the survey that you know and love very well. Like, for example, here is Kids, and also VHS, and for example, VVV is also very prominent, but to put it on this plot is actually divided by 3. You may see the very, very strong impact that Gaia DR3 and the foremost work had on the volume download with many of our users have actually downloaded product from the archive, also in conjunction with the Gaia DR3, but also preparation of the foremost observations. This is a different projection of archive usage. Here is number of files downloaded. And in this way to account for data download, we can see also the spectroscopic survey. Gaia ESO is a big player here. Gaia ESO released 200,000 spectra. And of course, here the number of files is divided by 10. About 2 million spectra has been downloaded for Gaia ESO, so it's been repeatedly accessed altogether. But then you see the big interest on VHS, and again, VVV is playing a big role, and also Viking and Kids and all the others. So, big success. I think I motivated or I prompted you on the impact that publishing data has through the ESO archive. Then I like to prompt this question. Please think about that. You'd like to see also your data to be published in the ESO archive. And if you're interested, please contact us. Also, ESO has an effective scientific visitor scheme. So don't be shy, come and work with us, talk to us. And I will conclude by thanking the data center, the external provider, all the team at ESO that supported the development of the Science Archive, CDS for Aladdin, IPSIS, and so on. And I look forward to the next 60 years.